Okay. So we already know that part A, the backwards direction of part A is true always for any function here. So I'm trying to make the forward direction false in the situation when the function is not onto. So I've actually got a picture of a function that's not onto. And so my hope is that I can make a function that is continuous. So in other words, I want pre-images of open sets to still be open. But I want to use at least one more set here. Can somebody give me one more set? Because I don't want to. I want it to be not the trivial topology. So I just need one more open set here, besides the empty set and all three elements. Can somebody tell me another set that I could make?
Can we say 1 and 3?
One, actually,
Or
both
two.
of you are right. You can use this one. What's the pre-image of that? The pre-image of 1 and 3 is actually everything in X, right? Which elements of X go to 1 or 3? All of them do, right? So this function, if I use, and do you agree that this is a topology? This should have been one of your 29 answers, right? So the pre-image of each one of these is one of these, because the pre-image of the empty set is the empty set, the pre-image of Y is X, and the pre-image of 1 and 3 is 1, 2, and 3. Now you could have, Jason suggested putting the set 2 here. That would also work because the pre-image of 2 is empty, and the empty set is in this topology as well. So with this definition here, F is continuous, right? The pre-image of every open set, there's 3 of them, the pre-image of every one of those 3 open sets is still open, but tau prime is not the trivial topology. So there you go. All right, so that does it. So these are kind of fun little questions. We get to create our own example. And something like this, you know, especially now in chapter 3, guys, with your examples, you don't necessarily want to start doing things like, you know, using complex, you know, even just the real numbers under the absolute value is going to be unnecessarily complicated. We can just get away with a very small little example to show what we're trying to say here. So. Yeah, so that's the problem. I'm already thinking of another test question. Like there must be like, if I assume F is 1 to 1 instead, like then something must have probably, my guess is that if I change the Y to the X as a trivial topology, probably then something like this would still be true for 1. I haven't thought it through, but that would be the sort of, that's the way I would act if I'm trying to write a test question. This is what the kind of thing you guys should be doing too, is like, how could I change this, right?
If it was 1 to 1, wouldn't it mean that only the null set could go into the null set?
Mm-hmm. True. Yeah, that's right. Yeah, the image of the null set would
Have to
be well, the image of the null set is always the null set. The image of actually, no, just the fact that it's a function means that the only thing that the image of the null set is the null set, but the image of anything else is not the null set. That's actually not because of 1 to 1. That's just generally true.
Okay.
Yeah. Anyway, I'm just encouraging you guys to like play with these ideas, you know. Maybe that might be a good question for the next practice quiz. I could just put it there. But stuff like that is kind of good to think about. Let's do one last problem, and then we'll call it a day. Okay, and this is actually one that is this number 6? This is this one is actually something I mentioned in class, and then I just didn't have time to prove it. So suppose X D is a metric space. So we're actually going to go back to metric spaces again. Prove that. So I mentioned that if you take the set of all neighborhoods neighborhoods, that would form a basis for the topology on the, so there, now we have a concept of neighborhoods again. And so the open sets in this metric space are just unions of neighborhoods. Back to chapter 2, right? So I said, well, if you just take the collection of all neighborhoods, that would be a basis for a topology. What is a basis again? So what's it mean? You got it there, hum?
X and tau is a topology space, and a subset of
It's like a script B. Yeah.
is open and tau is called a basis. For tau, every member of tau is a union of members of group B.
Okay, so it just means, yeah, exactly. So it just means that everything in tau, every open set, right, should be a union of sets that are in script B. So if script B is a set of all neighborhoods, that's a basis because every open set is a union of neighborhoods. Okay, but I'm going to ask you to prove something a little different. So unions of open sets, right? Everything in the topology should be unions of open sets of things from the basis. So if I take all neighborhoods, that's a basis for this metric space because every open set is a union of neighborhoods, and the neighborhoods are in the script B. What I'm going to do is I'm going to make script B smaller right now, and I'm going to call it B prime. And I'm going to say that these are just the neighborhoods around X of some radius P, such that X is in X, and P is a rational number. So I mentioned this in class, that you can actually make your basis smaller. You can say, I'm not going to take every possible radius for my neighborhood. It has to be like a rational number. So I can't have a neighborhood of radius pi, right? So these are just the rational numbers. And I would like to prove that this set is a basis for XD. Okay, so I'm just going to try to show that. What that means is I have to take an arbitrary open set in the metric space. An arbitrary open set, and I have to convince you that you can write it as a union of these guys. Okay? So that's what it would really mean. I know we haven't worked much yet with basis. The homework that you're going to do for Wednesday is going to be all about basis, working with this idea. So I'm going to let U be open in X. So we need to show that U is a union of things from B prime. Okay? Does anybody have an idea how we could start? Just what would be the very first thing you would do if you have an open set in a metric space?
Well, the open set in a metric space is a union of neighborhoods, right?
Very good, thank you. So that's exactly what we're going to do. We're going to write, I forget which proposition that is. Is that open, it's one of the, I've already forgotten which one that is. You don't need to know these numbers, but I just like to be able to give you the numbers to reference to. It's proposition 3. So by proposition 3, you're just going to write U as a union of a bunch of neighborhoods. Let's say X sub I, P sub I, where X sub I is in X and P sub I is greater than 0. So we can write U, which is an open set, as a union of neighborhoods. Now the problem here is that if the radii that we happen to have here are not rational numbers, then we have not expressed U yet as a union of things in B prime. The goal is to show that U is a union of things from B prime. I have U written as a union, but these guys, I don't know if they're in B prime because these radii that we were given from the proposition, we don't know anything about them except they're positive numbers. So it's a little bit of an issue that we have right now. Okay? Does anybody have an idea how we could, you know, make this work though? Sorry, this should really be, well, this is okay. There's an index set here. I just didn't write it down. Just to have it totally thorough. Well, so U, here's U. It's like a union. So here's xi, and here's some neighborhood there. And here's another xj, and here's a neighborhood there. And here's a neighborhood here. You're just taking each point, right? And actually, so these x of i's, obviously these x of i's are actually in U. Because x of I lives in this neighborhood, which is then inside of U. So let me fix that. Sorry. This is really inside of U. So x of I is, one thing you can do is you can take each element of U, right, and draw a neighborhood around it, right, that stays inside of U. And U is the union of all of those. Problem is the radii might not be good. The radii might be irrational. So can we massage this union somehow? Can we like change it in a way that still has U, the whole U is a union of neighborhoods, but now with the radii being rational? What could we do? Let's say that this radius right here is the square root of 2. So that's not good. What could we do?
Can we select which ones we want from all the unions?
Well, maybe you need them all. Maybe every single. I mean, what if it's the discrete metric and each neighborhood is just a singleton? If you like deselected one of those, you could get into trouble. What could you do? You're not happy with the radii that you have there. So let me give you an idea here. So let's say we have this point, and we have a radius here, and suppose the radius is the square root of 2. Let me give you an idea. Could I just make the radius bigger? Just jack it up to 3. Then it's going to look like this. Is that okay?
No.
Now you're still going to take a union of all these names. So if you imagine making all these little circles, make them a little bit bigger. Right? Go up to a rational number that's larger than whatever the radius was that you started with. Right? So if you make each one of these neighborhoods bigger, then is that going to work? Or am I going to run into a problem with this union? So I'll still have a union of open sets. But do you see what's happening with these unions, with these sets? They're drifting outside of U now. So you actually have a union, it covers U, but it's too big. Right? The union would be a bigger set than what U is. So so that was my idea, and it didn't work, but I'm hoping it will help you think what would be a good idea. So if I take the neighborhoods that I'm given, and I decide to just make all the radii a little bigger, so that the radii are now rational numbers, it's nice in the sense that then you've got your B prime set being used there, but the union is not U anymore. It's possibly some larger, something that's kind of a little bit bigger than U, right? Okay, so that didn't work. My idea didn't work. Does one of you guys have an idea what will work?
Can we take the smallest rational number or rational p then? Or
The smallest rational number such that what?
such that,
For P.
for p such that...
Is there a smallest rational number?
No.
No, P
No.
means,
What does he mean?
so we're looking for P that's inside of U, the neighborhoods that we have.
So we have
So
to
we look
take
at the smallest rational P and
So it's the I would say
inside
it's the
U.
infimum of all our p's,
Or the
such that p is rational. Can we say that?
What if none of these p's are rational?
Then
And I don't really want to compare them. So here's over here I have a radius that's this size. That has nothing to do with, this p over here is a really small one. Like they're not really related to each other. So taking an infimum of, and by the way, the infimum wouldn't even be rational necessarily. The infimum of this set, right, is the square root of 2, which is not
Which
even
is
rational.
irrational.
So yeah, so it's not quite the right idea, but so I just showed you that making the radius bigger didn't work.
make it smaller.
Thank
might
you.
work.
This is what I was trying to get to. Let's just shrink the neighborhoods, right? Shrink the p's, right? So shrink each pi. You don't even have to worry about how far you shrink it. Like you might say, oh, I need it to be really close to the pi that you started with. No, you don't have to do that. Just make it a smaller number, so such that pi is in q plus. So make it smaller, but such that it is still inside of q plus, right? So then I claim, the claim is that, can I just change this slightly? Well, let me just call this to pi star, such that pi star is in q plus. I want to make it clear that I'm changing the radius. I claim that if you take the union of the neighborhood around each point xi of radius pi star, if you do that, where xi is in u, right, I is in the index set, I claim that that is still equal to u. See, the risk, when we made the radii bigger, our set got too big. The risk of shrinking the radii is, well, what if it's too small now, right? I mean, definitely each one of these neighborhoods is still inside of the original one that we created it from, right? So we're making a new neighborhood. Let me just use a different, we're making a new neighborhood that's got a smaller radius there, right? So definitely, so in other words, what I'm trying to say, guys, is with this claim, I'm trying to say that this is clear. Because each one of these neighborhoods is just inside of one of these neighborhoods, which was inside of you. Right? My only concern is that when I shrank all those neighborhoods down, suddenly my collection in this whole union of everything doesn't get me the whole set anymore. What do you guys think? Is it going to work the other way? If I pick something here, will it live here? Pick something in U, does it live on the left side? Notice that this is a union over absolutely every single point of U. Every single element of U has a term that goes with it. It has a neighborhood that goes with it. So I actually am trying to convince you this is clear also. if you pick anything in U, right, it lives in its own neighborhood, right? One of these terms in this union is going to be that particular point, right? So so if I pick a point in U somewhere, then there will definitely be a neighborhood in my union that is centered on that point, and so therefore that point belongs to the union of all of these guys, right? Well, that's all you have to say. Xi is in the neighborhood of itself, a radius pi star, which is then contained in the union of all of those, and I'm out of room. But you know what I'm trying to say. Okay? So, what did we do, guys? We took an arbitrary open set, and we express it as first of all, as a union of arbitrary neighborhoods. We made those neighborhoods smaller, and now our open set is a union of things in B prime. And that's what a basis is. Every open set is a union of things from the basis. Okay? So, script B prime is a basis for the open sets in that metric space. Yeah, that's all it is. That's all it is. Maybe I should just say this one is clear since n of xi pi star is contained in n of xi pi. Just because you've made the radius smaller, so then that's just kind of clear. Yeah, that works. That's pretty good. How do you guys feel about this this problem here? So a basis is a union of neighborhoods. So maybe just real quick, I know I'm already over the 2 hours, but I just want to say, so for the homework, for Wednesday, the very first problem says, prove that the topology on R induced by the absolute value metric basically, so this is just a hint on your homework for the very first problem, for those of you guys who want to get started on it 4 days before it's due. It says prove that the topology on this space. Now what is the topology on this metric space? Well, the open sets are just the D open sets, right? So basically this is just unions of open intervals. Okay, so we're talking about unions of open. So an open set here looks like a union of neighborhoods, which is a union of open intervals. Prove that that topology is the same. In other words, the collection of all